The term thread is shorthand notation for thread of control, and a thread of control at its simplest definition is nothing but a section of code executed independently of other threads or other threads of control within a single program. What it means is basically you have a piece of code, and let's say if you have if-else logic, to keep it simple. At one point of time, the if logic can execute, and at other point of time the else logic can execute. So depending on the section of code that is getting executed, that becomes the thread of control. Okay. We'll come back to discuss how to create that thread of control, or how to do this multi-threading within Java. Before that, let me show you how a single thread execution will look like. Let's suppose we have a class called our class, and I have a method, and the method name is run, public void run, which simply prints message hello 100 times. And now I have another class, single thread demo, which has a main method that simply instantiates our class and calls the run method. So what happens in this case?
Println will be printed 100 times, right?
Right. So nothing great here, as simple as that. So what's happening? We have a thread. As soon as we this class enters the main method.
Professor, the hello will be printed 99 times, right?
0 less than, 0 to 100, If you put less than or equal to, it will be 100 times. Okay, 0 to 99 is 100 times, right? If you put less than or equal to, it will be 101 times. I starts with 0 and I less than 100, which is 99. 0 to 99 will be 100 times. If you make it less than or equal to, it will be 101 times, not 100. And instead, if you start I with 1, and if you make it less than 100, then it will be 99. Okay?
Okay.
So here what's happening, when this class is executed, single thread demo, there is a thread that gets started. And what is the name of the thread here? The thread name is nothing but main. The function name itself is main, which is a Java supplied function, static void main method, and the thread name is main, which is the default name of the thread for this main method. So a single thread has started, and the instantiation of our class has taken place, and using the reference for the our class method, run method, our class reference, run method inside our class is called. So if you look at the sequence of steps that's happening here, ignore this applet, substitute this applet for the main method in our case. So the main thread is doing some other tasks before actually executing the main method. Okay, and you can substitute this init for the main method.
Okay.
And then our class is instantiated here, and then the run method is called. You see the amount of time it takes to print the message hello 100 times. So the run method, our main program is waiting for the message, all the message hello to be printed 100 times.
Okay.
And then it's coming back to the main program and completing the rest of the statements. So essentially what's happening here is, once you call the run method from the main method, this program, the main program, is waiting for the other program to complete. before executing any further steps in the main program. So this is a single threaded model.
Okay.
We are not utilizing the CPU to the fullest extent. Let me show you the program for this in terms of execution single thread demo. We have a single thread demo method. I'm a class and I'm instantiating our class and I'm calling the run method, and I have a system print after the run method. So to prove that this main program is waiting till the run method is completed, I have a system out println. So this gets printed only after the hello message gets completed. That proves that this program is waiting for the run method to get completed and everything is happening in a single thread. Let me run it. So what happened here? You see, it started printing hello from the our class, and then after completing printing the hello message for 100 times, it came back to inside main. So it's waiting for the other class to complete its task before it can print the inside main. Okay? So this is a single thread model. There are no multiple threads happening here. There is no multiple threaded programming. Ideally, what can be done? Can you tell what can be done?
What can be done in do you want some
let me rephrase the question. Ideally, what do we want? What do we want is we don't want to wait for the So we don't want to wait for the other thing to complete, since there is no dependency in our case.
Yeah.
Right? As long as there is no dependency, why do we need to wait for our class to complete its execution before we can do whatever we want in the main method? We don't want that. So that's the problem with this single thread execution. If you look at this, what's happening? The task 1, if you assume this task 1 as a main method is calling the run method, main class is calling the run method, and run method is doing something. It can be anything, like as simple as printing hello message, or the run method can wait for some other IO, in which case the main method, the class is blocked till that IO part in the run method is completed, and then the next task is continued in the main class. Instead, what can be done is this wait for IO period. If there is no dependency, we can perform some other task in that time interval in a separate thread. So here comes the concept of multi-threaded programming. See, 2 threads. And how do you do that? And before discussing how do you do that, let's look at why do you need to do that. Improving performance with multithreading, as the diagram on the previous page implies, applications that perform several tasks which are not dependent on one another will benefit the most from multithreading to utilize all the resources as much as possible. For example, the task 2 can only be overlapped with task 1 if task 2 doesn't depend on the results of task 1. In our case, it's independent, and we can always complete the other task independent of the main class. Is that right?
Yeah. If none of the application is dependent on the other, it's expected to execute them concurrently rather than waiting and wasting time.
There is some echo coming when you are speaking, whoever it is. So just check that one. But yeah, so there is no dependency. However, some overlap between the 2 tasks may still be possible, even if task 2 depends on the results of task 1. If there is a overlap and there is a dependency, in that case, what should happen is the two tasks or the two threads must communicate so that they can coordinate their operations. So what this means is the threads can talk to each other, and how that can be done, we will discuss further. The point is the threads can talk to each other if there is a dependency between the two tasks.
What do you mean by talk to each other? What do you mean by?
See, what do you mean by talk to each other is, if thread 1 in the main method depends on thread 2 to complete its task, how does the thread 1 know? How does it know that thread 2 is complete? The only way it knows is the thread 2 has to notify the thread 1 that I am done, you can continue. And that will be done using a notify method, which we will see all those methods further down. So threads has the capability to talk to each other. Any questions? Hello? Guys, are you there?
Yes, sir.
Yeah, is it clear?
Yes, sir. Actually, me and Sushant are like sitting next to each other, so like we have muted one of the microphones
Okay.
so that the echo is not there.
Yeah, that's good. All right. So the threads have the capability to talk to each other. One has to notify the other thread that I'm complete and you can continue, and I will show you how to do that. But before that, how to tell that how the threads can communicate with each other, I will show you how to utilize this wait interval with another thread. Okay. So putting threads to work, what can be done is, we still have main method. Let's make another class called thread demo. We are instantiating a thread class. If you look at thread class, this is as simple as the other one. We have seen our class earlier. But in this case, this is extending a class called thread. That's it. This makes, once you extend this becomes a thread object.
Okay.
And once you instantiate that class, once you instantiate any class that extends thread class, you get a thread object. So here OC is a thread object.
Is a thread object, yeah.
Okay. And once you get a thread object, you are not done. Nothing has happened till now. You just got a thread object which is in a brand new state. The way to start multithreading is do OC.start. This .start is the key. So here what happens is the start method will internally call the run method, which is in the thread class.
Okay.
And this piece of code will execute in a separate thread independently, and it will die on its own when the execution is complete.
Okay.
And this main class will not block here, it will not stop here for execution, and it will continue to execute the next set of steps.
Okay.
So this one will take time, it will run in its own thread, and it will take its time to die. And this main class doesn't bother about that, and it will print the inside main first, and then the other thread will print this. Let me show you this example. So in the earlier example, you saw the inside main is printed after all the hello statements are printed.
Yeah.
Now, in the thread demo class, where I am using thread class that extends thread. Now, if I run this one, what happened?
Hello is printed, but inside main, I think it's getting printed earlier before hello is finished printing all 100 times.
Because that is faster.
Yeah.
So it doesn't wait for the hello to get printed. That is another thread that is running separately, and it will die on its own.
Okay.
Main has nothing to do when it will stop.
Okay.
That's totally a different thread. So that is the simplest way to explain you the concept of multi-threading.
But why hello is printed? But why hello is printed after inside main? Like, why not like first hello is printed, then inside main, then again hello?
That can also happen. First hello can print, and immediately inside main can print, and the rest of the 99 hello can also be printed. That's a good question. Because
sir, that depends on the processor speed, right? The sequence of execution.
Yeah, nothing is guaranteed in threads. If I am executing on my machine, and if you are doing the same programming on your machine and some other machine, inside main can print either for one at number 1, or after the first hello, or after the second hello. But the chances are inside main will get printed even before hello gets printed, because this is not a time consuming task. If you put some other loop here, okay, let me put some other loop here. That's a good question. So let me, in this case, hello main, inside main got printed earlier, right? And then all the hello gets printed. So let's put some other time consuming task like hello here instead of simple system out. Let's put this and see what happens, right?
Yeah, inside main.
I will do 10 times.
Okay.
Till now do this slowly. If you run this, still the inside main is taking, so let's do this 100, make it little more time consuming. Now to run this, it has to intervene. So this doesn't matter. If you run this same sample for n number of times, I have some other example down the line.
Yeah, it's here.
The second time, hello got printed in between the inside main. So that's why I'm telling nothing is guaranteed in threads. The sequence of execution is not under your control. There is only one way that you can control, using setting the priority of the thread, but that is as close as you can get to control the thread programming, but you cannot control anything further than that.
Okay.
And if I run this further 10 times, the sequence will change again.
Yeah.
Okay. See, again it came back to that. Now let me run again. So it depends. Okay.
Yeah.
So that's how it works. Now, if you look at the next slide, when you're putting threads to work, what happens? The interval of execution of printing hello message is very short, because now it takes its own route to do that, and the main gets ended earlier than that. Okay?
Yeah.
So why threads? In many applications, multiple activities are going on at once, and process is a single process, but you can make best use of the process by spanning multiple threads, and threads are also lighter weight, and threads can speed up the process using the parallel techniques. You can use the best use of all the resources available, and it's easy to communicate among themselves. Now, how do you create threads? There are two ways to do this. The first way, you already saw that in the current example. you can do that. You can create a thread object by extending a thread, and it is simpler to use in small applications, but the limitation with this approach is you can't extend anything else once you extend thread, because Pradeep or Bhavik,
What's up? We can't extend.
you can't extend anything else once you extend the thread class.
Okay.
Because
Anything else? Thread.
see, in Java, you can extend any class. You can extend only one class, but you can implement.
Oh, yeah. Got it.
You can implement n number of classes, interfaces, but you can only extend one class.
Okay.
So once you extend thread class, you lost the opportunity.
Okay. Let me just note it down, sir. Okay, sir.
Yeah. And the second way to get the thread object is by implementing runnable interface. Okay. More general, since the target object can
Professor, when you said that you can't extend anything else, like can you give an example?
See, Java doesn't support multiple inheritance, whereas the C language supports that. You cannot, in Java, you cannot extend from multiple classes. You can only extend one class. Okay. See, I think we missed the earlier classes regarding when we talked about superclass and subclasses.
Okay.
Any subclass can extend only one superclass. What does it mean? Any class can be child of only one parent.
Okay.
But a parent can have multiple subclasses. Parent can have multiple children, but any children at single point of time can have only one parent. So once you use that, and the keyword to subclass, a superclass, is by using Java keyword extends. And once you extend thread class in this case, if you want to extend any other utility classes, you cannot do that. You cannot say extends thread comma some other utility class. So as much as possible, you have to always implement the interface so that you will have an opportunity to extend some other classes at later point of time in your application. If you are still not clear on this, talk to Pradeep on subclasses and superclasses. Just follow that session. I have sent the slides for them.
Okay.
I will get it. The second way to create a thread is by implementing runnable interface. So I will show you that. Before we go there, how to implement runnable interface, let me quickly show you what are the constructors for a thread class. A thread class has a default constructor, and it can also accept a runnable target, which is a runnable interface, and it can also accept a runnable interface or a reference implementation of that with a string name. Guys, did you get when I said like it can accept runnable interface or a reference implementation of that? See, when there is a thread class and that accepts a runnable interface, let me show you this.
Sir, it is like redefining the methods that will be there in the runnable interface, right? When you are like designing a particular thread based on your requirement.
Redefining the methods?
Yeah, like suppose you want.
You mean override?
Yeah, overriding. Yeah.
Yeah, you will override. You will override the method here.
Mm-hmm.
Let's say the method is run method.
Mm-hmm.
You'll override. But what I mean here is when a thread class constructor accepts runnable interface, what and all you can assign to this runnable. Either you can pass a reference of the runnable interface or any implementation of the runnable interface.
Okay.
Similar to if you have a superclass, I told you superclass can be assigned with the reference to a subclass.
Subclass, yeah.
Similar to that, when it comes to interface, we can assign an interface a reference implementation of the interface. Okay. So runnable IMP in this case implements runnable interface.
Okay.
So to the thread class constructor you can pass this R because you have assigned an implementation, reference implementation of the runnable interface.
Okay.
Whereas when it comes to subclass and superclass, you can assign superclass a subclass reference, subclass implementation. Okay, so here you can pass either a runnable target, runnable interface, or a implementation of that. And the other version of thread constructor.
Just a minute, sir.
Yeah.
Just a minute. Hello?
Yeah. And the other version of thread class here is it can accept runnable interface along with the name, and thread class is just a name. Okay. That constructor.
Like in case of this third constructor, thread. So this is the reference, right? Runnable. That is the reference.
That's the reference, and it can also accept. This is the name of the thread.
Okay.
You can also thread class has a method to set the name of the thread.
Okay.
If you don't set the name of the thread, by default the thread name will be like thread. If you have two threads, by default the thread names will be thread 0, thread -0, and thread -1.
Okay.
See, the first one, by extending thread, you have seen, let's suppose you have a class called target, and target extends thread, and you have a run method, and in the main method you do this thread equal to new of target. So now you get the thread object because this target class extends thread class.
Yeah.
Now nothing has happened till now, and unless and until you do that thread object dot start. This start method will internally call its run method. Okay.
Okay.
Let's suppose you don't do thread dot start, and I try to do thread dot run. What will happen? Will it run in a
thread dot run? It should run.
No, it will run, but will it run in a multi-threaded program?
No, it won't run in a multi-threaded mode because that is like giving a call to a particular function of an object.
To a particular method.
Yeah. Oh, sorry.
To a particular method of the object. That is the first example we saw. That's the single-threaded model.
Okay.
Right? I showed you that inside, that's separate. So you have to always do the start. What happens when you start a thread? A new thread of execution starts with a new call stack.
Okay.
And the thread moves from the new state to the runnable state. Here you have to understand the subtle difference between runnable and running. A runnable thread is a thread that is ready for running, but it's not necessarily picked up by the thread scheduler and it's not running yet. It just is available, the thread is available to run, and it's up to the JVM thread scheduler whether to pick that thread or not. There may be hundreds of threads that are ready to run, but the JVM decides which thread to run before what. If there are 100 threads that are in same runnable state, not all of them necessarily runs at the same time. When it actually runs, when it is picked up by the thread scheduler, that thread becomes running. So when you call start method, the thread moves from the new state to the runnable state, which is better than the new state. And when the thread gets a chance to execute, its target run method will run. So what does it mean by thread getting a chance to execute? That is nothing but the thread getting selected by the scheduler.
Okay.
You always call start on a thread instance, not on a runnable instance. What does it mean is, see here you created a thread object and you call the start method on the thread object. And even if you implement runnable interface, you should always call the start method using the thread object.
Okay.
How do you do that? I'll show you in runnable interface.
I'm confused, sir. Can you repeat once again?
See, you should always call the start method on a thread instance, on a thread object. In case of when you're extending thread class, no problem. You do thread equal to new target. So this is a thread object. You can directly say thread.start.
Okay.
Because this is a thread object. But when you come to implement runnable interface, this target is implementing runnable interface.
Okay.
You do target equal to new target. This is a target object, no problem.
Okay.
I mean, this is a runnable object.
Okay.
Because this
It is implementing
this is a reference implementation of runnable interface.
Okay.
But this is not a thread object.
Okay.
So how do you get a thread object?
Okay.
That's why I showed you the constructors. For the thread constructor, you have to pass the runnable target and you get the thread object. Right? You see the second method, thread runnable target. You get that? Now I'll show you here. You got, what is this target? This is a reference implementation of the runnable interface. Or simply say this is an implementation of the runnable interface. Are you clear till that?
Okay.
And now you want a thread object to call the start method. So just pass that runnable interface to the thread constructor and get the thread object. And use that thread object to call the start method in case of when you implement runnable interface.
Okay.
So there is an additional
constructor.
Sorry?
Using that specific constructor where we pass in the object reference.
You are passing what here? What is this?
The runnable reference, right?
Not runnable reference. This is an implementation of the runnable interface. So this is a class. Target is a class that is implementing runnable.
Okay.
And you always need a thread object. So what you do, you pass that runnable interface implementation to the thread constructor.
Okay.
And from that you get a thread object. And you use that thread object to call the start. Confused?
Okay, sir.
Yes.
Okay, good. So here in this case, when you are implementing runnable, there is an additional step. You need to get a handle of the thread object before you can call the start method.
Okay.
But the other implementation, the run method remains the same, no change. Now look at this. This one is simple one. Yeah, it's no problem. Now let's look at, till now we have seen, I have shown you an example of a single thread and also multiple threads earlier. Now look at another example, how to start and run multiple threads again. Earlier we have seen that printing the hello message and inside main can get mixed up when you are running two threads, right? It's not necessary that main gets printed always first and hello gets printed next. Depending on various runs, they may interleave between each other. Now to reiterate, just I'm showing you how to start and run multiple threads. So you have a main method and you have simple class. This simple class implements runnable interface, and you have a run method here that prints the value of I and the name. You are passing the name to the constructor of the simple class, and the simple class implements runnable interface, so you have to get the thread object. So you pass that simple class to the thread constructor and you get the thread object. Similarly, you have another simple class and you are passing that simple class to the thread constructor and getting the thread object. So you got two thread objects, thread 1 and thread 2. Now you are doing thread 1 dot start and thread 2 dot start. What gets printed? Guys, if you are on mute, just unmute and let me know what gets printed here.
PG will be printed along with the iteration.
Okay, and what about the thread? Yeah, what about
and
thread?
Thread 2, Jamaica will be printed along with the iteration. Can we just go back to those definitions? Yeah. Simple. Yeah. So PG will be printed along with the corresponding iteration for thread 1, and okay, same way for thread 2.
Okay, but which one will get printed, either Fiji or Jamaica?
Assuming that thread 1 starts first, PG will be printed and then followed by Jamaica, or it could be anyway. It could be next, depending on the processor.
That's right. That's the point I'm trying to show you here.
So we have to set a priority for that, right?
Yeah, right now we haven't come to set the priorities, but without the priority, anything can happen right now at this point. Okay, so if you see the output, either Fiji can print 4 times and then 3 times Jamaica, and then the 5th time, the other time Fiji can print. So mix and match.
Okay, just a minute, sir.
Yeah.
Yes, sir.
So let's look at, so those are the two ways to get the thread, implement the thread. Let's look at some methods from the thread class. One is sleep method that accepts milliseconds and nanoseconds. There is another version of sleep method that also accepts nanoseconds. We'll see what each of these methods will do with an example later, but first let's get a feel of what are the methods within the thread class. One is sleep, one is yield, one is join, and the other one is set priority.
Okay.
And if you have followed the exceptions handling class from yesterday, see this sleep class throws interrupted exception.
Okay.
This is a checked exception. So this method defines that, okay, this method is capable of throwing an interrupted exception, and as well as join.
Okay.
And what are the methods from the object class related to the thread programming is or wait, notify all.
Okay.
Okay, this is important. What are the methods from the thread class? Can you tell some other methods from the, object class?
Object class, notify, synchronize.
Synchronize is not from the object class.
Okay, object class, hash code.
Yeah.
And then hash code is there. What else is there?
Hash code, finalize, toString.
Finalize. Okay, yeah.
toString, wait, notify, all. Yeah.
Okay.
Oh. These are all the methods from. These are some of the methods, not all, from the thread class that we have seen just now. Don't worry about this description. When we come to the specific example, I will tell you what each one of those does. What is sleep, what is yield, what is current thread, is alive. I'll explain you all those. Let's look at the life cycle of a thread. So before you call thread.start, what is the state of the thread? It's in a new state.
New state.
And when you call thread.start, thread_object.start, it will be in a runnable state.
Okay.
And when the thread gets picked up by the scheduler, it will be in running state.
Running state.
And while it's in runnable, while it is in running state, there is a method, static method called yield. And if that method is called on the thread object, what it will do is the thread will yield to some other threads to execute. So it will stop executing and it will let the other threads execute on that particular piece of code. So in that case, when the thread_object.yield is called, or the thread class.yield static method is called, the thread moves from running to runnable state.
Okay.
And if any of these wait, sleep methods are called on the thread object, it moves from runnable to not runnable state.
Okay.
Because sleep is, okay, don't execute this thread for the next 5 seconds or 10 seconds.
Okay.
And when it is sleeping for that specified amount of time, whenever a notify or notify all comes from the other thread, it moves back from not runnable to runnable again. It won't be running again. It just becomes runnable and the thread scheduler has to select again.
Yeah.
So let's expand this thread life cycle and understand a little more. At any given point in time, a thread is said to be in one of these several thread states as illustrated in the below diagram. The new and runnable, either blocked or waiting, and terminated. Terminated is like a dead. Thread is dead. Okay. And blocked and waiting, these are non-executing threads. These are not doing anything. The thread constructor is called to create a new instance of the thread class, and when the thread constructor is called, that will be in new state, number 1. That is step number 1.
Okay.
And when you call the start method is invoked to designate the thread as runnable. So now it is in runnable state. This is step number 2. And the Java thread scheduler runs the thread as the processor becomes available, and it will be from runnable to running. Okay. If the thread invokes wait method, it will put the thread into the waiting state and it will remain there until another thread invokes the notify or notify all. Okay, that thread doesn't know that when a wait method is called on the thread object, it will move to the state called waiting. So step 4 is missing here. I think step 4 should be about blocked.
Interrupt.
Yeah, interrupt. Step 6, the thread ends when the run method terminates.
And sir, who will notify that particular thread which is like waiting?
The other threads.
Okay, okay.
Other thread will send a notify signal.
Okay. The thread on which like this particular thread which is waiting is dependent, right?
Yeah, that it's waiting, and the other, whatever the current running thread has taken the control. Once it completes, it has to notify, and if it doesn't notify, this other thread, whatever is waiting, will be in waiting forever.
Okay.
So someone has to notify that.
Sir, I think Bhavik cannot hear. That's what he's saying.
Cannot hear. What happened? He says I'm back. Okay.
Okay.
This 4 is here. It should have been there in the other.
Yeah.
So the thread can become blocked for various reasons, and it will not run again until it is returned to the runnable state.
Okay.
Now look at this summary of states for a minute, and then it will look at the more detailed. So when the state is new, the thread has been created, but it's not started. It's important to understand all the states of the threads. And runnable, the thread's start method has been invoked, and the thread is available to be run by the thread scheduler. And a thread is in the runnable state may actually be running, or it may be waiting in the thread queue for an opportunity to run. It depends on the thread scheduler and the resources available. Blocked, the thread has been temporarily removed from the runnable state so that it cannot be executed. This can happen if the thread sleep method is invoked, or if the thread is waiting for an IO operation to complete, or if the thread requests a lock on an object that is already locked. This concept, if the thread is waiting for a lock on an object that is already locked, I am going to explain it in the synchronization part. Even in this case, that thread, if it is waiting on another lock, I'll explain you what is a lock a little later, but if the thread is waiting for some other lock, it will be moved to a blocked state.
Okay.
And waiting, the thread has invoked its wait method so that other threads can access an object. The thread will remain in the waiting state until another thread invokes the notify or notify all method. And the thread's run method is ended, it will be terminated. So look at this slightly different view, but combines pretty much all the states of the thread, the life cycle. Now let's look at each one of those.
Sir, one question. When a thread goes to sleep, right, by invoking the sleep function, so it will be like put back to the runnable mode automatically, or does it have to wait for another thread?
No, it will be put back automatically once the timeout period ends. If you say let the thread sleep for 5000 milliseconds, which is 5 seconds, the thread will be in runnable mode again, but it will not be running. Again, it has to be started by the
dispatcher, scheduler.
Yeah, scheduler.
Okay.
Yeah, it's the same thing that we talked. A new thread, and when a ready thread begins execution, running state, blocked state. When it terminates, here we need to talk about a couple of new things here. Is alive method is used to query the state of a thread. That is one of the methods of a thread class. What it does is it will tell you whether the thread is alive or not. When a thread is considered to be alive is just before the thread becomes, just before the start method is called, or as soon as the start method is called. As soon as the start method is called, it will not be in start mode immediately. There is a ramp up period there, a little bit of ramp up time there. So it will be in between new and start mode, but the thread is still alive there. And similarly, as soon as you say, as soon as the run method ends, it is not dead also. As soon as the run method ends, there is also a ramp down time there for the thread to be dead, and between. Yeah, tell me.
Hello.
Yeah.
In the Israelite part,
Guys, can you hear me?
Yes, I can hear you, but there is an echo there.
Hello.
Yes.
This is Bhavik. Sorry to disturb. I just got the microphone right. So.
All right, great, man.
Okay.
Sir, the question I was asking, like here they are mentioning about blocked running state and ready. Does the block state include the waiting part also?
That the block state includes waiting. There are two different states.
Yeah, that's why. Will it show a true value for the thread is in a waiting state?
No, is alive. The thread is alive as long as it is not dead. Yes.
Okay. It will show true for all then.
Yeah, true for all.
Except for, okay, fine.
Except when the run method completes and there is a little ramp down time after that, but after that the thread is not alive, but most of the time the thread is alive.
Okay.
So for that you can use this isAlive method. Is used to query the state of a thread. This method returns true if the thread is in ready, blocked or running state. Doesn't matter. Okay. It returns false if the thread is new and has not just before calling start method, it's in new state, but at the time the thread is not alive. Okay. So as soon as the thread you call the start method, then the thread becomes alive. Okay. And or if it has finished, the thread is alive will return false. Mm-hmm. And when the thread is executing, there is also an interrupt method that can interrupt the thread. And when you interrupt the thread, it can throw what exception? I showed you the checked exception.
Interrupted exception.
Yeah. So it can throw an exception. That's why those methods that can throw interrupt exception has to be in what blocks?
Try catch.
Yeah, it should be. Those should be in try catch. So the interrupt method interrupts a thread in the following way. If a thread is currently in the ready or running state, just a minute, guys.
Okay.
So if a thread is currently in the ready or running state, its interrupted flag is set. If the thread is currently blocked, it is awakened and enters the ready state. Mm-hmm. So don't worry much about this interrupt signal and all.
Okay.
We will not use too many times that one. Mm-hmm. This is the same thing we talked about at OS level, how the states change between different states between ready, running and blocked versus waiting and all.
Okay.
So let's talk about the critical part. A critical region is a part of an object code that should not be accessed concurrently. Let's take an example of the bank account. It's a common example that's discussed when talking about multi-threading. Hold on a minute. 1 minute, guys. Let's suppose you have your account has two people can access your account. Let's say your checking account.
Okay.
One of you and preferably your family member, right? Let's say joint account. And if you both happen to withdraw from the account at the same time, what can happen is if the if the programming is not has not taken care of this synchronization part, the amount will be withdrawn once, and when the other person is trying to withdraw, it will still think that the amount is available even if there is no balance, and it will try to dispense the amount from the ATM.
Okay.
So essentially the point is here only one thread should execute that piece of code at any point of time. Only one thread in the sense one for one object, one object, how do you put this, one thread in the sense like for different accounts each thread can access, but for the same account only one thread can should access that piece of execution.
Yeah.
Let's put it in
Exclusive.
a simple way. Yeah, exclusive. So we know we have P++. Let's say take this expression is decomposed like the way it works is retrieve the value of P and increment by 1 and store the value of P. This is what we want. What happens if two threads A and B call this P++ simultaneously, assuming P equal to 0 initially? What thread A is trying to retrieve P and thread B is also trying to retrieve P. Thread A increments that P to 1 and the thread B also increments to 1. Thread A now stores the value P is now 1 and thread B is also storing that value P is now 1. If we have synchronized this part of code when two threads executes, and if P is a common variable, when thread B executes this, that should have been 2 instead of 1. Because when thread A executes and stores it as 1, and when thread B executes that value should be picked up as 1 and it should be incremented by 1 more and it should be stored as 2. To avoid these kind of issues, Java provides a keyword called synchronized. Java provides a few simple structures for synchronizing the activities of threads. And these are all based on the concept of monitors. A monitor is nothing but essentially a lock that is attached to a resource that many threads need to access.
Okay.
This is the part I was talking before regarding the locks.
Okay.
When a particular piece of code is locked and another thread is trying to access that, and if it is locked, that thread has to be in blocked state or waiting state.
Okay.
So the resource is accessed by one thread at a time. One thread at a time for a particular object instance. Let's say there are multiple object instances, 10 objects for the same class. Each of those objects can have single thread accessing that code. That's not a problem. But for any particular object instance, only one thread should access the code. So you can always have two threads for a particular object instance, right? How do you get that?
Two threads
Thread.
for a particular object instance.
Yeah.
Particular object instance. So
So you say thread T1 equal to new of our class,
okay.
and or put like this. Our class implements runnable interface, and you say our class O1 equal to or let's say new class extends thread class to put it in simple terms. Thread T1 equal to
New the new class, right?
new our class, and or even before doing that, if you say our class O1 equal to new our class, you can do thread T1 equal to O1 and thread T2 equal to O2. So here T1 and T2 are threads for the same instance.
Okay.
So right, in this case T1 and T2 should not be able to access this kind of critical parts of the programming at the same time.
Okay.
But T3, which can be another instance, O2, our class O2 equal to new our class, that can access, because T2 is another object instance for the class.
Okay.
And a different thread. That's not a problem. So the way here synchronization works is each Java object in the brackets instance has a single lock, one lock per object.
Okay.
You have to understand that instance, each Java object instance has a single lock, one lock per object.
Okay.
The critical regions of the object are protected using the synchronized keyword. Okay. Whenever these kind of critical programming parts are there, they are protected using the synchronized keyword. Only the thread that has the lock of the object has access to the critical regions. The thread that enters that piece of code first will get the has to get the lock of that particular piece of code.
Okay.
That synchronized keyword will make sure that that particular thread will get the entire access for that particular piece of method, synchronized method.
Will there be a case like that two threads are accessing the lock at the same time?
Yes, there can be a case, and that will be a race condition. Only one of them will get the access, and the other one has to wait in the waiting.
So, how it will decide?
No, based on this, the synchronized method will make sure only one thread will get the access. Whatever thread gets the access first, the other one has to wait. Right? Again, it's depending on which one the thread scheduler picks up first. We don't know which one gets the access first. Any one of them, but the guarantee over here is when the method is synchronized, only one thread will get the access, not both of them at the same time.
Okay.
As long as the thread owns the lock, no other thread can acquire the same lock.
Okay.
You see this, many threads are running for the lock, but only one of them can get it.
Okay.
And the other threads will be blocked waiting for the lock to be released. And when the lock is released when the method returns and the method execution completes.
Okay.
Example of synchronized methods. There is a class called counter, and we have a couple of methods to increment the value of the instance variable C and to decrement the value of the instance variable C. There is another method, say hello. Can I ask you why there is no synchronized keyword before the say hello method?
Because C, like here they are considering C to be a part of a critical data.
Yes.
So there has to be a consistency with the value of C. Whereas
Yes.
it is just a print statement, hello, and which is like in this case is not considered to be a critical data.
That's right. We should not use this synchronized keyword often. It should be used very minimally, because what's happening essentially is this reduces the amount of parallel programming, right? Parallel number of threads that can execute.
Yeah.
Right? So you should use that very minimally. And this say hello is not.
If you are using it too often, it will like end up having a single threaded application, right?
Yes, but again, this thread, the number of threads is per instance. You can always execute single thread for other instances. That's not a problem. But still, it's essentially a fewer number of threads can access that when compared to the synchronized not there.
Okay.
That synchronized keyword is for the method and not for the class here. So
Okay.
why did I say that synchronized keyword is not for the class? So the advancement to this is, can you synchronize a static method or a static how do you say, yeah, can you say, if let's suppose there is a static method, how do you synchronize that static method? This void inc is not a static method here.
Mm-hmm. Void INC is not a static method. We are using synchronize to synchronize it, right? And in case of static methods, Professor, it is like only one copy will be there, like accessible by all the objects, right?
Yeah, only one will be there. So in that case, what we need to do is, instead of synchronizing at the method level, you need to synchronize at the class level.
Okay.
Because only one method, one copy will be there for all the object instances.
Mm-hmm.
And let's suppose there are 10 object instances for that class. You don't want any other object instance to modify the values inside that static method while the other object is working on it.
Okay, so like, are you trying to say that we can use synchronized method for a static? We can use the synchronized keyword for a static method.
Yes, you can do that.
Okay.
But the lock in that case will be at a class level, not at the method level.
Class level in the sense how?
Okay, I'll show you that. Let's let me show you. Okay. See, this one is at the method level, right? And this is not a static method. If it is static, I told you it's one instance per class. And so the other object instances should not access at the same time. Okay? If you synchronize at a class level, that restricts the access for the other objects. So the keyword, if you put at a class level, let me show you that. Synchronized class. Don't have example here, so I will show you one synchronized class example from synchronized, yeah. I don't have the example ready, but look into that, how to synchronize static methods and you get the lock at class level. Okay? Or we'll look into this after this class. All right? Pradeep? Hello,
Yes,
guys?
sir.
Yeah. So now look
Actually,
at,
I was on mute.
yeah. So now look at the another version of that. If you, what happens if you put the synchronized keyword for a method? So when you put the synchronized keyword for a method, the entire method is blocked by that, is blocked, and none of the other threads for the same object instance can execute that, right?
Yeah.
So essentially you're wasting, like if there are non-critical parts of the code within that method, you don't need to block the entire method. So there is another version of synchronized called synchronized blocks, which is a little less than, I mean you are not blocking the entire method, but you will be blocking only a few lines of code in that case. Blocks of code protected from concurrent execution by a monitor. Let me show you some example. This code is critical. Now this code is not critical. Now what you do, instead of blocking, mentioning the synchronized for the entire method, this is not critical line, right? And this is critical. If you see this, C++ is critical, whereas this println within the INC method is not critical. So you synchronize only on this block.
Okay.
So this is called synchronized block. This is an interview question. What is the difference between a synchronized method and a synchronized block?
Okay.
In synchronized block, you will not block the entire method, so that you will leave the non-critical parts.
Okay.
Can you explain once again the example?
Yeah.
For method and block.
Okay. See, the synchronized method earlier, if you see here, you have only one statement. C, increment the C and decrement the C. It doesn't matter if you, in this case, it doesn't matter if you synchronize at method level or a block level. But if you have some other statements, in this case, some other system println, which is not critical, you don't need to, and which is not dependent on C, the value of C. You don't need to synchronize at the method level and synchronize only at a block level. So instead of mentioning the synchronized keyword at the method level, this is critical, this is not critical, just put the synchronized keyword right above the piece of code that you want. So this braces and this synchronized keyword and this this is a object on which the lock will be obtained. This is a synchronized block versus a synchronized method in the earlier case. Okay. Sushant? Is it clear, Sushant? Are you on mute?
Solely that line of code gets blocked, right?
Sorry?
Solely this particular line of code gets blocked in synchronized block, right? That's
Yes,
what you're
yes.
saying, right?
Yes, yes.
Okay.
Not the entire method. Pradeep, look for that example. How to, you can, after this class, just look for how to synchronize a static method. Okay?
Okay.
We are not discussing static methods here. I don't have, I haven't taken any example for that. But my point is that can also be done. So what are these? Run on, coordinate the action among the run on synchronized blocks. Okay, we are going to talk about now the methods that we have seen earlier from the thread class: wait, notify and notify all methods, and sleep methods. Threads that invoke the wait method, what happens is, if the particular, let's say a particular thread has entered the synchronized block, or a particular thread and it has called the wait method on that object. So if it is in waiting state, it doesn't need the lock anymore. And what happens is, when the wait method is called, the lock is released, and the thread goes comes out of that synchronized block and it goes into the waiting mode, so that other threads can execute that synchronized method or the synchronized block.
Okay.
Threads which invoke the notify method wakes up one waiting thread. We don't know which one. There may be many. Thread scheduler doesn't specify which one it notifies, but one thread will get notified for the when the notify method is called. But there is another version of notify, threads which invoke the notify all method. It wakes up all threads.
Okay.
But again, we have to notice understand here that notifying all threads doesn't necessarily mean that all will become running.
Yeah. That depends on the scheduler.
Again, some of them has to be picked up.
Okay. And sir, one more question.
Yeah.
Can you go back to the previous slide? Here it says thread which invokes the wait method releases the lock of the object, right?
Yes.
Suppose I'm in my critical section with regards to the bank account. I have deposited like $100, okay? And now all of a sudden, like I'm invoking the wait method. So that $100 transaction which I have deposited in my account, it will be in effect, right, before the other thread takes the control.
Yes. See, those kind of critical parts has to be atomic. What does atomic means? Is the deduction and the dispense of the amount to you at the ATM has to happen in one place at one shot.
Okay.
So in that cases, those kind of situations, this wait is a programmatical execution. The wait is not called from somewhere else.
Okay.
That's a method you need to implement or call. That's a method you need to call when you need it, but it doesn't necessarily mean that you do such kind of things when you're writing critical pieces of code.
Yeah, just for like example, like I took that scenario.
Yeah, right. But yeah, those kind of things has to be taken care to be atomic. But you know what? Those kind of things, even it's not guaranteed that one single thread completes the deduction of the amount and the dispense of the ATM.
Okay.
So that synchronized will rescue us in that case.
Okay.
That is like to make sure that those transactions are happening all at one time.
Okay. Yeah.
Notify all. When the notify all happens, the threads that are waiting will try to reacquire the lock, and whatever thread gets the lock again, that will continue again.
Okay.
But any point of time, only one thread will be executing within the synchronized method, for instance. Okay.
Yeah.
Because each instance variables are independent of the other variables, unless and until those variables are instance variables that are static.
Okay.
And for static, the lock has to be obtained at a class level so that that won't create an issue. That's what I was telling earlier.
Okay. Can you just repeat, sir, like what you told now?
See, only one thread must be executing within the synchronized block at any time or synchronized method.
Okay.
But one thread per instance. So if there are multiple instances, multiple threads can run. But multiple threads of the same instance shouldn't run at the same time.
Okay.
But those are for non-static variables and non-static methods. But in case of static variables, multiple threads cannot be run at the same time if that piece of code of static variables is critical, because the static variables are shared across different object instances, and that should not happen. So in that case, we should acquire the lock at the class level.
Okay, fine.
Okay. It can become even more complex discussion, like a static method can access only static variables, and there are cases like what happens if a non-static method can accesses a static variables. These kind of combinations will also come. So if you want to understand in detail, so try to get hold of these kind of things, how the threads works, thread synchronization works in these kind of situations. It can become as complex as we can get into that. So threads are like very interesting, but at the same time we need to understand the intricacies of all these details. Okay. So now let's see. There is an example here. Go through this slide. When you are done, I'll show you the next one, and you have to tell me what happens here in this case, based on your understanding.
Okay.
Bhavik, if you can unmute your microphone
Yeah.
and there is so there is a print char, there is a main method in test thread, and we're creating 3 threads. Through print char class that is extending a thread, and the other one is print num, which is also extending a thread class.
Okay.
So nothing much difference between that print char and print num. Both override the run methods.
Yeah.
So now tell me what happens when you start print 20 dot start, print a dot start, and print b dot start. If you want to look at print num, let's take a look at this print num. But this is not doing much. It's just printing from 1 to the whatever number we are passing as an argument. So now Bhavik, your voice is breaking. Can't hear you. Yeah, one of you go ahead, Pradeep or someone. So just tell me what do you think is happening here.
Just a minute, sir.
If you want to look at print num, I will move the slide. Let me know.
Oh, okay, just a minute. Times equal to 20. Can you go to the next slide? Okay. 20 times. Okay, and can you go back to the previous slide, sir?
Yeah.
Now the next slide. For print num. Sir, in case of print num, print 20, it will be printing 20 times the value 20. Okay. And for print A and print B, which belongs to print char class, these objects, they will be printing A 20 times and B 20 times respectively.
Okay.
And but the order won't be it won't be in a specific order. Depending on the processor speed, it will vary from one processor to another.
Yeah, that's right. So if you run this similar to our example that I have shown you earlier, see the sample executions notice that output from 3 threads is interleaved, and also notice that the output sequence is not repeatable. It may be repeatable or may not be repeatable.
Yeah.
Okay. So now look at this other version of this. Now tell me what happens. I'll move to this once you're done with this.
Mm-hmm. Implements runnable and okay, we're passing 20. Okay, print it. And here we are passing the runnable reference, right, to the thread.
Okay.
Okay, I might not be like telling you the proper words, but it is like the class that is implementing runnable is passed to the thread object, right?
Class that is passed to the thread constructor, yes.
Yeah, thread constructor, and then with the help of the thread object, we are like printing the same thing again that we did in the previous section, like A20 times, B20 times, and the value of I20 times.
Yeah, and same thing. Yeah, random order. So it's just to reiterate to your understanding, like you can do either using extends threads or implement runnable.
Yeah.
This gives you like little bit of confidence, right?
Yeah.
Now let's do a little bit of modification to the earlier example. To illustrate some of the methods in the thread class, you might want to try a few modifications. The one we want to do is use the yield method. So let's say in the run method, you did this thread dot yield. So yield is a static class from the thread method, so you can directly call using the class name dot method name.
Okay.
Now every time a number is printed, the print20 thread yields. So each number will be followed by some characters. So that yield, what it will do, it will let the other threads run.
Yeah.
So each number will be followed by some characters. That's what the yield thread dot yield will do.
Okay.
Okay. And when you use sleep, let's say you are doing, how do you use sleep? Sleep is another static method you can call using with the thread class name dot method name. In the run method, you are putting like in the last num 1 to 20. If the number is greater than 10, let the thread sleep for 2 milliseconds. Okay. And because this sleep method can throw an interrupted exception, you have to put it in the try catch. Otherwise, the compiler will throw an exception.
Okay.
Because it is a checked exception, it's not unchecked exception. If it is a checked exception, you have to put it in the try catch. Now, every time a number is greater than 10 is printed, the print20 thread is put to sleep for 2 milliseconds. So all the characters will complete printing before the last integer is printed.
Okay.
Now, this is little more interesting about the join method. What the join method will do is, you can use join method to force one thread to wait for the another thread to finish. Okay. Take the current running, modify the code in the run method to do this. You are doing print a dot join. Now the numbers greater than 10 are printed only after the thread print a is finished.
Okay.
Because you are doing the join, numbers, the current thread is will be forced to wait for the other thread to finish. And what is the current thread? The thread that is printing the numbers. That will be
This is in regards to the print num class.
This is for the print num class. Yes.
Why it's greater than 10 and not less than or like equal to 10?
This is the numbers is if I equal to 10.
So it will be like 10
Yeah,
and greater than 10.
10 and greater than 10. Probably just try with greater than 10 also. So try these methods like sleep, join, wait, and see how it goes. And the output may vary each time you execute. Okay.
Okay.
And the sleep class has different constructors. Like it can accept time in milliseconds and time in nanoseconds also.
Okay.
If you specify long time in milliseconds, comma time long time in nanoseconds, that combined time will be the time for which the thread will sleep. So the interview, one of the questions asked is the difference between sleep and wait.
Okay.
Wait will wait for the notification, whereas sleep will
wait for notification.
Yeah, it will wait for the specified amount of time and it will return to the runnable state again.
Okay.
So,
Just a minute, sir. Okay.
now let's look at an example of how do you call sleep method. You are printing a date, the current date, and saying thread goes to sleep at what time, right? And then you are making the thread sleep for 10 seconds, which is 10,000 milliseconds.
Okay.
And when you print the date again, so the time will be a little more greater than 10 seconds.
Okay.
Plus the time to execute to create this new object, which will be in nanoseconds, right? So here if you see started at 5:15, or if you take this 5:16, 31 seconds, and the thread sent to sleep for 10 seconds, and the next thread wakes up at 5:16, 41 seconds.
Okay.
Yeah. Now let's talk about thread priorities. So till now, if number of threads are in a pool, the thread scheduler doesn't guarantee which one will get picked up first. But if you set the priority of a thread, there is a little more probability that the higher the priority, those threads will get picked up by the scheduler earlier than the other threads, because the threads with higher priority are more important. Every Java thread has a priority that helps the OS determine the order in which threads are scheduled. And Java priorities are in the range between 1 to 10. Okay, 1 is minimum priority and 10 is the max priority. Threads with higher priority are more important. However, thread priorities cannot guarantee the order in which threads execute. You can just try giving the priorities, but still it's not guaranteed. Nothing is guaranteed in threads when it comes to threads. By default, every thread is given a normal priority, which is 5. And each new thread inherits the priority of the thread that created it. So the default priority is 5. So let's see this. Five is a normal priority, whereas the minimal priority is 1, and if the max priority is 10 given to, let's say, thread A and B, A and B will be executed first and may be executed first, or maybe picked up for or maybe scheduled for thread priority, and then C, because it is having only 9, the other ones C, F are having 7, and if you navigate to down all the way to J and K at only priority level 2. Alright, so that's it, guys, regarding threads.
Great.